Now, in this video, we're going to look at momentum, and we're going to discuss how to solve question to do with momentum. If you're new to Proflan YouTube channel, consider subscribing so that anytime I'm going to do more tutorials like this, you'll be notified. So we're going to look at what's the kind of questions you can be asked in momentum and the best way you can be able to approach them so that you can be able to maximize the number of marks. So if you look at this concept of momentum, you need to understand, what do we mean by the term momentum? Momentum is defined as the product of mass and velocity of an object. Any object that is moving has something we call momentum. So whenever you are asked to calculate momentum, you're going to use the formula momentum is equals to mass times velocity, and the units for momentum is given by kilogram meter per second. A key thing that you have to remember is the formula for momentum, which is well illustrated here. And you have to remember that mass has to be in kilograms. Also, you have to remember that velocity has to be in meters per second, so that whenever the question comes, you can be able to answer that question with lots of ease. Also, within this topic, you need to remember the relationship between force, mass, and acceleration. And force, mass, and acceleration is given by the formula for the equals to ma. And also, we can talk of the concept of force is the change of momentum over the time taken. In momentum, we usually use final momentum minus initial momentum divided by the time taken. That is going to give you what we call force. Also, before we dive in, you need also to remember the concept of the law of conservation of momentum, because the concept of momentum before collision is equal to momentum after collision is also another concept that is going to be tested whenever the question asks question to do with this. So let's begin so that we can be able to see the kind of questions that have been asked previously as far as the concept of momentum is concerned, and the best way you are going to approach it. If you're new to Profile YouTube channel, consider subscribing so that anytime I'm going to do further tutorials, you'll be notified. Let's dive in so that we can be able to get started. So in this particular question here, we put the tennis racket is used to hit a tennis ball, and we are told that the time in contact is time contact is 0.2, and then it leaves at 46 meters per second. We're supposed to say the question relating acceleration, tension, velocity, and time taken. So in this particular case, we're going to say that acceleration is equal to change in velocity or divided by time taken. Acceleration of the tennis ball, assuming that it's at rest when it hits, so meaning that initially when it hits, it becomes at rest, and then it moves at 46 meters per second. So which means that acceleration is going to be final velocity minus initial velocity over the time taken. And if we are going to use that, we shall say now this is 46 minus 0 divided by the time. We are told here it was at rest for duration 0.2 seconds. So which means that here we're going to put 0.2 seconds. If you work it out, you're going to get your answer 230 meter per second square. So you ought to remember, whenever you are having a question to do with calculations and they don't indicate the units, you have to include the units as meters per second square, and it's 230 at that given point. So the question relating momentum, mass, and velocity. So we're going to say momentum is equal to mass times velocity. And from page 2 of this worksheet, you can see I've already given you the relation between momentum, mass, and velocity. It's well indicated here. So you can see now whenever you have this worksheet from Proflan, you can be able to access the formulas related to every topic that you're going to be accessing. And if you would like to download this, you can be able to access these worksheets in our Patreon page so that you can go to have it in your desktop or your tablet so that you can work it out. Calculate the momentum of the tennis ball when the velocity is 46, so which means that using the formula momentum, so mass times velocity, and that is we're told the tennis ball was how many grams. So we provided that information. It was 57 grams. So that this 57 grams you have to divide by 1,000 so that you can be able to convert it to kilograms, so that you can proceed from there. So meaning that if you just put this into your calculator, 57 divided by 1,000, that is going to translate to 0.057 kilograms. So we are going to use the mass of 0.057 kgs. Don't work with grams. So you got 0.057, then multiply by the velocity, which is 46, and if you work it out times 46 there, you're getting 2.622 kilogram meter per second. So basically that's what you're gonna get in the process of working out this particular question. So if you look at the raw data was given, mass was given two significant figures, also was given two significant figures, also can give answer as two significant figures, 2.6 kilogram per second, and that is perfect. Well, let's proceed to the next bit. so that we can be able to see what is the next question. The bottom of the tennis player's shoes are thick, made from material that compresses when the player hits the land when the player's feet lands on the ground. So explain why these shoes reduce the risk of injury during injury to the tennis player. So how do these compressing shoes reduce injury in the process? So at that case, we're going to say, as the shoe compresses, it increases the time of impact. As the shoe compresses, it increases. Sorry, I need to write it here. It increases the time of impact. It increases the time of impact. For the same changing momentum. It increases the time of impact for the same changing momentum. And since force is equal to changing momentum over time, then increase in time reduces the force. So you can see from this formula, changing momentum stays the same, but the time increases, which means that increase in time reduces force, because force and time are inversely proportional. And also that you need also to understand and also to remember, as far as this topic is concerned, is the law of conservation of momentum. You must know how to state the law of conservation of momentum. So in that case, we're going to say total momentum before collision is equal to total momentum after collision, provided no external force. Okay, let's leave it there. We don't want to extend it because we are just talking about so, well, the diagram shows how the object A and object B moving in opposite direction. So this is approaching this direction, and also they are moving towards each other. State the magnitude momentum of B before collision. Momentum of B before collision. So before collision, object A has a momentum of 39. After collision, A and B stick together. So B is moving in opposite direction. So which means that this is after collision, object A and B stick together and they stop moving. So if one object was having momentum of 39 and the other one was having an equal stop, it means their momentum were equal. Right? So this also must be 39. Formula that gives momentum, mass, and the velocity is momentum is equals to mass times velocity. You can write it once. And what's the mass of object A? Okay, the mass of object A, remember the point of momentum of 39. So meaning 39 is equal to the mass, which is 8.1, times its velocity, and that is equal to 39 divided by 8.1. And if you work it out, you're going to get 39 divided by 8.1, this is going to give us 4.8 meters per second. Yeah? The time taken before collision, the time taken for the collision is 0.56. I can have the force on object A. I get the average force on object A. Remember, when these objects collided, they stopped. So the object A was having initial momentum 39, and this stopped, so the changing momentum was 0 minus 39, momentum initial minus, sorry, the final minus initial. So which means changing momentum, we don't mind of the sign, so we're going to say changing momentum for A is actually 39, because it was having 39 and it stopped, then it means it's going to have a change of 39. Then therefore, force is usually changing momentum over time taken. So it's going to be 39 divided by 0.56, which is the time. So if we can be able to work out, we're going to get 69.6. It's approximately 70 newtons. It's approximately 70. If you write this to two significant figures, give the direction and magnitude of force on object B from A. So A is moving in the direction, so the force will be acting to the right. So the force will be exerted on B, so we can say the force will be to the right, and the magnitude of the force will be also 70 because so we can say the right. That's direction is the one we should say to the right. But the magnitude will be 70 newtons. 70 newtons because according to the constant law for action is equal and opposite reaction. So if A experienced a force of 70 newton, it's also going to exert a force of also a force of 70 newton on you. So if you exert a force on the object will exert an equal and opposite direction force on you. Looking at question number 3, it says okay, this is moment of force. I'll look at check the link for moments, the tutorial for moments. I'll have to skip that. State Newton's third law of motion. It states that for every action force, there is equal and opposite reaction force. So for every action force, there's equal and opposite reaction force. So which means that if we have a gentleman who is standing next to the wall, and this guy try to exert a force on the wall, then it means that if he exerts a force to the wall, then the wall will also exert an equal and opposite force back to the gentleman. So if you push a table, the table will also exert a force on the wall. Okay, let's look at also another question to do with momentum. The diagram shows, okay, right. This one is not from height above the ground. And we have a diagram showing the ball the instant it's released. Draw label out to show force acting on the table at this. So the force acting on this ball, the instant that is released, is actually the weight of that ball, the one that will be acting down. So immediately it starts moving, it's going to start experiencing now air resistance or an upthrust force. Diagram 2 shows the tennis ball at the instant it hits the ground. Just before hitting the ground, the tennis ball is moving downward at a velocity of 2.5. Right moving the 2.5. Just after hitting the ground, the tennis ball moves upward at this speed. So it hits and then it moves upwards. Now the tennis ball is 0.57 kg, and then it's supposed to create a change in momentum. So we can consider down to be positive, and we consider upward to be negative. So you can assign and you also assign upward to be positive and down to be negative. But for me, in the case here, I've decided that I'm going to consider down to be positive and up to be negative. So initial momentum is when the ball is going down. So that's going to be the mass, which is 0.057 times 2.5, and it's going down. So I'm going to consider that positive 0.057 times 2.5, and that's going to give me 0.1425. Final momentum. Final momentum, I'm going to consider it moving upward, so I call it negative. So that's going to be 0.057. I multiply by 1.9. So 0.057 times 1.9. If I work out that, I get negative 0.08, oh sorry, 0.1083. Therefore, we can calculate the changing momentum. Usually changing momentum is given by the formula changing momentum is equal to final momentum minus initial momentum. So in that case, changing momentum is equal to final, which is minus 0.1083 minus 0.1425. So we're going to add these two, so it will be 2508. That's all. And the sign here, it means that the momentum will be now acting. You see, we can say this negative to be upward. So the negative sign here, it means that the ball will be having a momentum moving while it's moving upward. That's what I mean. But since we're just after calculating momentum, so we initialize just a positive number and link with the kg meter per second. So basically that's what we're going to do in the process of as stating that. Well, if you wish to write those figures, and as well write those figures, and you would like simplify. The ball is in contact with the ground for the time of 6.0 milliseconds, and then you are supposed to calculate the force, the direction of the force. I think we are going to use this sign to know the direction, so the direction will be upwards. Because we are saying the momentum is down is positive, upwards negative, and since we're going to keep here, the force will be acting upwards. And remember, force is equal to changing momentum divided by time, which means that we can be able to say 0.2508 divided by 6.0 divided by 1000 divided by the cost of milliseconds. So we convert this to seconds divided by 1000. And most students will have gotten this question wrong because of that. So if you watch out, you're going to get to answer the equivalent to basically the cost of 42, 41.8 neurons, so we can write as 42 as our final answer at that given point. So basically this is exactly what you're going to get whenever you are given a question here. Well, what I should do on this day. See the difference.